In this video, I'm explaining first order nonlinear differential equations and how to solve them. So, what is a first order differential equation? First order differential equation means it contains only first derivative of an unknown function. That is, if y is the unknown function, it has just dy by dx. What is a nonlinear differential equation? Nonlinear means the degree of the dependent variable and its derivatives is more than 1. Linear means y as well as dy by dx or its derivatives must be having the degree equal to 1, then it is called as linear. If degree of the derivative as well as the dependent variable, that is y, if it is more than 1, then that is nonlinear. Another condition for nonlinearity is the dependent variable and its derivatives can be multiplied together. So you can have the product y into dy by dx or y square into dy by dx, like that. So in that case, we call the given equation as nonlinear. So first order nonlinear means you should have just dy by dx and power of dy by dx is more than 1, and you can have the product y into dy by dx whole square or y square into dy by dx whole cube. So all that are valid in the case of nonlinear equations. One more case can contribute to the nonlinearity. That is, if you have any term with like sine of y or e to the power y dash, all these contribute to the nonlinearity because this is a nonlinear in y. See, if any one of these three conditions hold, then we call it as a nonlinear differential equation. So, if the degree of the dependent variable is more than 1, that case it is nonlinear. If you have product of derivative and dependent variable, in that case also it is nonlinear one. To say it as a nonlinear, all three conditions need not satisfy at a time. If you have any one of these three conditions, then we call it as a nonlinear differential equation. See, for example, dy by dx plus 2y equal to 5. This is a linear differential equation because degree of the dy by dx term is equal to 1 and you do not have derivative and its dependent variable multiplied together, and degree of or power of y is also equal to 1. You don't have these kind of non-linear terms, hence this becomes a linear differential equation. Suppose if I write like this, dy by dx whole square plus 2y equal to 5, in that case it is not linear, it becomes non-linear differential equation because this condition is satisfied. Any one factor is there that makes it non-linear, that is enough. So in such cases also, the first order differential equation becomes nonlinear differential equation. Examples, see dy by dx whole cube minus cos x plus e to the power x into dy by dx whole square plus 5y into dy by dx plus 2y square equal to 0. Look at this equation. It is of first order because you have just the term dy by dx. No higher order derivatives. And it is non-linear because see, power of dy by dx is 3 here. It is more than 1. In this case, it is 2. Here it may be 1, but there are terms with power of dy by dx which is more than 1. So this is first order nonlinear differential equation. Similarly, this one, xy into p square plus 1 equal to x square plus y square into p, where p is given by dy by dx. So just to make our simplifications easier, instead of writing this dy by dx every time, if we replace dy by dx by p, then the equation will be in terms of p. You have to check the power of p, that is more than 1, therefore it is non-linear. And look here, dependent variable and its derivative, They are multiplied together. Y square into dy by dx you have here. And moreover, the power of dependent variable is 2. That is also more than 1. That all contribute to the non-linearity. Therefore, these are examples for first order non-linear differential equations. So, any first order nonlinear differential equation is of the form f of x comma y comma dy by dx equal to 0. It can be written as a function. That function has the dependent variable, the independent variable, and its first derivative. So if you name that first derivative as p, then this becomes f of x comma y comma p equal to 0. So in a more general way, we can write the first order nonlinear differential equation as p to the power n plus p1 into p power n minus 1 plus p2 into small letter p power n minus 2 plus on up to pn minus 1 into p plus pn, which is equal to 0. So where p, small letter p, equal to dy by dx, that is the derivative of the function, and all these p1, p2, p3, so on up to pn, these are functions of x and y. So this is the general form of first order nonlinear differential equation. So this is all about first order nonlinear differential equations. Now let us see how to solve these equations. Every first order nonlinear differential equation need not be solvable. So there are few equations which can be solvable, and there are few equations you can't get the solutions of such equations. So if you have few equations which can be solved, then what are the ways of solving the equation? Because bringing it into the standard form and solving it in the standard form itself is difficult. Therefore, we have four categories, four ways of solving the first order nonlinear differential equations. Let us see those one by one. See here there are four ways. Type 1 equation solvable for p. Type 2 equation solvable for x. Equation solvable for y, and Clairaut's equation. These are the basic four types of solving a first order nonlinear differential equation. Because whenever you have the first order nonlinear differential equation, so in that case, you have to first check, is it possible to factorize the left hand side. So if it is possible to factorize the left hand side, then you will get equation solvable for p. If it is not factorizable, so in that case, you have to go with the other possibilities. Is it solvable for x, solvable for y? Is it a Clairaut's equation? And so on. Let us do that one by one. Now, first case is equation solvable for p. See the first question. Solve p square plus px plus py plus xy equal to 0. So this is nothing but dy by dx whole square, because p is dy by dx, plus x plus y into p, that is dy by dx, plus xy, which is equal to 0. Now look at this differential equation. Clearly it is of first order because there is only first order derivative, and it is non-linear because the power of first order derivative is 2 here, more than 1, as well as here dependent variable is multiplied with its derivative. That also contributes to nonlinear. At least if satisfies one condition, that is enough to say it as a nonlinear differential equation. So this is first order non-linear differential equation. Now it is equation solvable for p, means you can get its solution in terms of p, that is p square plus x plus y into p plus xy equal to 0. This is a quadratic equation in p. That means it is solvable for p. You know the general form of quadratic equation, that is ax square plus bx plus c equal to 0. This is a quadratic equation in x. And how will you get its solution? Using the formula. So here instead of x you have p. So equation solvable for p, minus b plus or minus square root of b square minus 4ac divided by 2a. So here a equal to 1, b equal to x plus y, and c equal to xy. Here a equal to 1, b equal to x plus y, c equal to xy. So p equal to minus x plus y plus or minus square root of x plus y whole square minus 4 into a is 1, c is xy divided by 2 into a is 1. So minus of x plus y plus or minus this is square root of x plus y whole square is x square plus y square plus 2xy minus 4xy. So that is x minus y whole square. Square root square cancels, you will get x minus y divided by 2. So simplify this further. P equal to minus x minus y plus x minus y by 2, or P equal to minus x minus y minus x plus y divided by 2. So here minus x plus x cancels, P equal to minus y, or P equal to minus x. So we got here p equal to minus y or p equal to minus x. Let us simplify further. P is nothing but dy by dx equal to minus y, or here dy by dx is equal to minus x. This is a first order equation where you can go with the variable separable method. So that is dy by y equal to minus dx, or dy equal to minus x into dx. Integrate on both sides. You will get here log of y equal to minus x plus c1, some constant of integration, or here y equal to minus x square by 2 plus c2. So this is nothing but x plus log of y equal to c1, or here 2y plus x square equal to 2c2. So I can take C1 and C2 as C, or C1 and 2C2 as a new constant C. So x plus log y equal to C, or 2y plus x square equal to C. Therefore, general solution of given equation is obtained by writing it as the product of these two individual solutions, that is x minus x plus log of y minus c into 2y plus x square minus c equal to 0, because I can write this as x plus log y minus c equal to 0, and this as 2y plus x square minus c equal to 0. So general solution is given by taking the product of these two solutions, that is x plus log y minus c into 2y plus x square minus c equal to 0. This is the solution of the given differential equation, which is obtained by solving it for p. Now second type is equations solvable for x. So let us see how to solve these kind of equations. First problem, solve p square y plus 2px equal to y for all x and y and p greater than 0. See here, first you have to rewrite the given equation in terms of x, that is 2px equal to y minus p square y, 2px equal to y minus p square y, then x equal to y by 2p minus p square y by 2p. So that is equal to y by 2p minus py by 2. So this is the given equation in terms of x, because it is solvable for x. You can make this a separation because it is solvable for x. Now, after doing this, you have to differentiate this equation 1 with the respect to y. So, you will get dx by dy, which is equal to here. So 1 by 2p I will keep outside. Then differentiation of y with respect to y is 1. Product rule I am applying. uv whole dash is uv dash plus vu dash. So y in 1 by 2p into derivative of y with respect to y is 1, plus y into derivative of 1 by 2p is, So 1 by 2 is a constant. Derivative of 1 by p is minus 1 by p square into dp by dy. Similarly, minus here also product rule again. You can keep 1 by 2 outside because it is a constant. P into derivative of y with respect to y is 1 plus y into derivative of p with respect to y is dp by dy. So after this, dx by dy means 1 by p. That is because dy by dx is p. Therefore, its reciprocal is 1 by p. This is 1 by 2p. This is plus into minus minus y by 2p square into dp by dy. Then minus p by 2 plus into minus minus y into dp by dy divided by 2. Now all p terms on one side, so 1 by p minus 1 by 2p plus p by 2. This is equal to here from these two terms take y by 2 into dp by dy common with a minus sign. Therefore, what remains here 1 by p square plus 1. 1 by 2 also taken outside, y into dp by dy taken outside along with the minus. So minus of minus plus, here also minus of minus plus. Here 1 by p square remains, here 1 remains. Now let us simplify this further. So this is 2p is the LCM. You will get here 2 minus 1 plus p square equal to minus y by 2 into dp by dy into p square plus 1 by p square, taking the LCM here. Now when you simplify this, this becomes p square plus 1. So I'll write here, this is p square plus 1 by 2p equal to minus y by 2 into dp by dy into p square plus 1 by p square. So p square plus 1, p square plus 1 cancels. 2 cancels in the denominator, 1p cancels. Therefore, finally you are remained with 1 equal to dp by dy with a minus sign. Along with that you have one y here and one p here. Rest all got cancelled. Now cross multiply. So wherever you have dp, keep that p here. Now y take it to the other side. So you will get, so here y take it to the other side. So you will get dy divided by y equal to minus dp by p. This is a first order linear differential equation solved using the variable separable method. So this is equal to integrating on both sides. We'll get log of y equal to minus log of p plus I'll add constant of integration as log c. This is natural logarithm. So you'll get log of y equal to log m minus log n is log of m by n. So log of c by p. So log cancels here, y equal to c by p, or else you can write p equal to c by y. Now this value of p has to be substituted in this equation 1, either here or here, anywhere fine. So what you will get is, therefore I'll write here x equal to p is c by y. So y by 2 into 1 by p means y by c minus y by 2 into p is c by y. Now let us simplify this. Gives you x equal to y square by 2c minus y cancels c by 2. So the equation was solvable for x. Therefore, you will get the general solution. This is the general solution of equation 1, which is in terms of x equal to y square by 2c minus c by 2. So this is how we solve first order nonlinear differential equation. That equation is solvable for x. The method is, first you write it in terms of x equal to function of p and y. Then you have to differentiate that x with respect to y. Then you will get a value of p in terms of that y. Substituting back the value of p in first equation eliminates that p, hence you will get its general solution. Now third type is equations solvable for y. One example, solve y plus px equal to p square into x to the power 4. So that is y plus dy by dx into x is equal to dy by dx whole square into x to the power 4. This is a non-linear first order differential equation. Non-linear because power of dy by dx is more than 1. First order because there is only dy by dx term. So where dy by dx is replaced by p. Now this is an equation solvable for y because we can write it as y equal to p square x to the power 4 minus px. So this is equation 1. Name it as 1. Solvable for y means you can write the given equation as y equal to function of p and x or function of x and dy by dx. Now, once you have written it in this form, what you have to do is same as before, but now differentiating with respect to x. Earlier case differentiating with respect to y because we wrote the equation as x equal to function of y and p. Now here y equal to function of x and p. Therefore, you have to differentiate with respect to y. So you will get dy by dx equal to p square. Use the product rule. uv whole dash is uv dash plus vu dash. P square into derivative x power 4 is 4x cube, that is with respect to x, plus x to the power 4 into derivative of p square is 2p into dp by dx because it is with respect to x. So dp by dx term is must, minus similarly here px product rule again, u into derivative of x with respect to x is 1 plus x into derivative of p with respect to x is dp by dx. Let us simplify this. Dy by dx is nothing but p equal to 4x cube p square plus 2x to the power 4 into p into dp by dx minus p minus x into dp by dx. Now from these two terms you have to take common, then these two terms take it to the left hand side. So p plus p 2p minus 4x cube p square equal to, here you can take x dp by dx common, then you will get here 2x cube p minus 1. Here 2x cube p remains, here x dp by dx taken common means 1 remains. Now here also you can simplify it in the same way, that is if you take minus 2p common, then you will get minus of minus plus here 2x cube p minus 1 is equal to x into dp by dx into 2x cube p minus 1. So this get cancelled. You have here minus 2p equal to x into dp by dx. So you can go with the variable separable method now. So that is here dx you take it to the other side. So dp, bring that p here, dp by p equal to dx by x with a minus sign, that is minus 2 into dx by x, or else you can do dp by minus 2p equal to dx by x. Anyway it is fine. So here I have brought only p this side, then dx to this side divided by x. So you will have minus 2 dx by x equal to dp by t. So integrate on both sides. I will get here log of p, natural logarithm, minus 2 into log of x plus some constant of integration. I'll add it as log c because simplification becomes easier. Here log p equal to, again same, log of m minus log of n is log of m by n. So log of c by x square. How x square here? M into log a is nothing but log of a to the power m. This goes to the power of x. Log of x square with a minus sign. So log m minus log n is log of m by n. So log cancels, you will get p equal to c by x square. Now you have to eliminate p from this equation. So that is y equal to 1 implies y equal to P is c by x square. P square is c square by x power 4 into x power 4 minus p is c by x square into x. So this is equal to x power 4 cancels. C square minus c by x. So is equal to y. So y equal to c square minus c by x, or else you can take LCM and write it in the simplified form xy equal to xc square minus c. This is the general solution of equation 1, which is obtained by writing the given equation as y equal to f of x comma p, then differentiating with respect to x, getting an equation for p in terms of x, then back substituting that value of p in the first equation to get the general solution of the given differential equation. This comes under type 3, that is equation solvable for y. Now fourth and the last type is Clairaut's equation. The general form of a Clairaut's equation is given by y equal to px plus f of p. Px term, then any function which contains only p. Now the general solution of this Clairaut's equation is given by y equal to cx plus f of c. Just you have to replace p by c. This is a nonlinear and first order differential equation. This kind of equation is called as Clairaut's equation. General solution is given by replace p by arbitrary constant c, that is y equal to cx plus f of c. How to get the singular solution of this equation? Singular solution is nothing but it is without arbitrary constant c. That means the constant c to be eliminated. That solution is called as singular solution, and that singular solution represents envelope of family of curves represented by general solution. So general solution gives you the family of curves because c is their arbitrary constant. When you go on giving different values for c, you will get a family of curves. So this singular solution, what it gives is, it gives you the envelope of these family of curves, and in that singular solution there is no arbitrary constant. That let us see one example for Clairaut's equation. So solve y equal to xp plus p square. This is of the form y equal to xp plus f of p. Here f of p equal to p square. How to get its general solution? General solution of this equation 1 is y equal to xc plus c square. So now we need the singular solution. So it is find both general solution and singular solution. Now I need the singular solution of this. Singular solution means it is without arbitrary constants. See, therefore what you should do is you have to differentiate equation 1 with respect to p partially. This is partial derivatives. You have to differentiate equation 1 with respect to p partially. When you are differentiating with respect to p partially, x and y both are treated as constants. So derivative of y with respect to p is 0, x is a constant, derivative of p with respect to p is 1 plus p square derivative, that is 2p. It is with respect to p partially. So you will get therefore p equal to minus x by 2. So this is the value of p. Once you got the value of p, you have to substitute back into first equation. So equation 1 implies y equal to x into minus x by 2 plus minus x by 2 whole square. So that gives you y equal to minus x square by 2 plus x square by 4. So after simplifying this, that is by taking LCM, 4 is the LCM, here you will get minus 2x square plus x square, which gives you 4y equal to minus x square. So x square plus 4y equal to 0. This is the singular solution of the given equation. Singular solution means this doesn't contain arbitrary constant, and this represents the envelope of family of curves represented by this general solution. This is how we solve Clairaut's equation. Therefore, totally there are 4 basic types of First order nonlinear differential equations. The first type is equation solvable for p, means the left hand side can be factorized for p. If the left hand side cannot be factorized, in that case you have three options: equation solvable for x, solvable for y, and Clairaut's equation. Equation solvable for x means you have to write x equal to f of y comma p, then differentiate with respect to y, get the value of p, back substitute the value of p in the equation to get the general solution. Similarly, solvable for y means write y equal to f of x comma p, then differentiate with respect to x, get the value of p, back substitute in the equation to get the general solution. And Clairaut's equation is in this form. General solution is given by replacing p by c, and the singular solution is given by differentiating partially with respect to p, the given equation, then get the value of p, back substitute in the given equation to eliminate that p. Hence, you will get a singular solution of the given nonlinear differential equation. I hope you understood the concept. Thank you for watching.